Hey everyone, my name is Jeffrey Mew and I'm a program manager here at Microsoft for the Python Data Science and AI team in Visual Studio Code. Specifically, I'm working on all things related to Pytorch in VS Code right now. And you might be asking, how did this all start? Well, Pytorch has recently become actually the fastest, if not the fastest growing Python machine learning framework out there. But the tooling portion hasn't really been kept up to its growth. And when we talked to the community of Pytorch developers, we found that there's a huge gap and lack of good tools to develop Pytorch within the market. So because of this, we've been working with the Pytorch team over at Facebook to make the Pytorch development in VS Code a first-class experience, and we want to make VS Code the de facto tool for Pytorch. So today I'll be going through a typical machine learning project in VS Code, and I'll be walking you through step-by-step throughout the project, from the data exploration phase of this machine learning workflow to the training phase, where we're going to be trying to figure out our model and doing our compute and maybe potentially tuning our model, and finally to the deployment and inputing of your model so that it can be used for other services and used by other people. And alongside this, I'll be showcasing all the Pytorch and data science features that VS Code has to offer. Great, so to get started with VS Code, if you don't already have it installed, you can just go to code.visualstudio.com right here, and just to download it for your computer. It's free, open source, and cross-platform, so it'll work on any machine. But once you actually have VS Code installed, let me just shift to my VS Code. You'll need to go into the extensions tab. So you see this extensions over here. Click this, and then you can search for the keyword Python. So just search for Python. It should be the first one made by Microsoft, and that once you download this is where all the Python Jupyter Notebook related functionality for VS Code live, and that's where all the Pytorch and data science features that I'm going to be showcasing today reside as well. Great, so now once we have everything installed and set up with VS Code and the Python extension, we can get started. So everyone's talking about stocks nowadays, and you've probably heard of colleagues or friends talking about GameStop or Tesla stock. So I decided to get into the fun of it by building a simple Pytorch project to try and predict and model the Microsoft stock price. We'll just be using the historic stock price of Microsoft as a dataset, and we'll also be using Pytorch inside of Jupyter Notebooks to build and train the model. Quick disclaimer, I'm not a financial expert here, so this project's just for fun, and if this model worked 100% of the time, I would probably be rich by now. But without that out of the way, to get started, I have my Pytorch project here already opened up in VS Code, and I already have my Jupyter Notebook called stocks.py1b opened up, which is where most of my Pytorch code for this stock price model is living. And although I'll be using Jupyter Notebooks for this project and demo, most of the features you'll see today can be found while you're working with a regular Python file or Jupyter Notebooks, whichever one you're more comfortable with. And although I'll be stepping through the code a bit quickly, since the focus here is mostly around the tooling, feel free to pause the video anytime to look at the code in more detail, and also be including a link to the GitHub repo at the end itself as well if you are more interested. Cool, so going back to the ML workflow diagram here, we can see one of the first steps with any Pytorch or machine learning project is the data exploration phase. So here's where you're going to be figuring out what your data set is, doing the data cleaning and pre-processing and loading into your computer. So that's what we're going to be doing first. I have this cell right here. What it does is I'm actually using the Yahoo Finance API to get the Microsoft stock prices, and I'm going to be using pandas to load it into a data frame here. So to run the cell, I can click this run button here, or actually can just click Shift Enter to run that cell. So you can see it just ran right here. And rather than printing out my data frame, because I actually want to see what my data looks like at some point, and rather than just printing it out here and looking at a crude snippet of it, I can actually use VS Code's built-in data frame viewer to look at my data in a much more human-readable format. So to do so, I just need to open up the Variable Explorer first. To open up the Variable Explorer, I can just click this Variable Explorer icon on the top right, and then the Variable Explorer will open up in the bottom. And the Variable Explorer is super powerful because it keeps track of all your active variables as well as their most up-to-date value. So it just brings a lot of order to the chaos that is your Jupyter Notebook. And then if I want to access the data viewer, I can just open up the variable I just created here, so it's df. I can just click this, and it'll open up in what we call our data viewer. So the data viewer, as you can tell, is an Excel-like interface for data frames or just array-like objects. And within the data viewer, I can do a lot of powerful things. So I can quickly filter values, sort values. So for example, if I want to look at the earliest date or the latest date, you can see the earliest date here is 2016 March 15th, and the latest date is today's date that I'm filming the video. As well, I can quickly sort values and search for values if I want to. And then the more cool thing is I can actually see all of my columns at a glance. So here, it makes it easier to figure out what my game plan is of how I want to clean the data and which columns I need and which columns I need to get rid of. So for this stock price prediction model, I'm going to be looking at the columns. I'm probably going to be needing this close column because that's what we're going to be predicting against. The close represents the closing price of the stock on this date. And I also need the date just because it's referencing the date of when this close was as well. So knowing that, I can go back to my code and just write my code there, run my code where I will only want to select the date and close columns, which I have here. And again, I can just hit Shift-Enter to run. And if I want to see my up-to-date value, because I've just reassigned it to this data frame, I can actually click this refresh icon here, and it gives me an up-to-date value of what my data is. So it's a really great sanity check to see that I'm actually grabbing the correct columns and my code is doing the thing I expected it to do. Okay, so looking at your data in the data viewer is really nice, but one thing you'll want to do with any Pytorch or even data science project is to actually plot your data to view its trends more visually. So what's nice about VS Code notebooks is that they support interactive IPy widgets and also interact widgets, such as Plotly, which is one of the most popular ones that are Python plotting libraries out of the box. So you can see here I just plotted the Microsoft stock price over the last few years, and it's a Plotly graph. So because it's a Plotly graph, it's all fully interactive. So you can see I get tooltips. I can select different ranges I want to look at. I can even export it. And this is way more powerful than just working with a traditional matplotlib static graph. Cool. So now that I have a pretty good understanding of my data set, it's time to actually pre-process the data so that we can prepare it for the Pytorch model. We'll want to apply some transformations on the data to better normalize it, because you can see these numbers are kind of like arbitrary, like at least according to the model and all over the place. So oftentimes if you're applying several transformations in a row, it's hard to see if your transformations are giving you the correct result. And again, this is where the data viewer and the variable explorer comes in really handy, because as I'm applying the transformations, I can actually see the size of the variable, so I can make sure that it's the expected size that I want. So not that like I'm dropping rows. I don't want to drop like 80% of my rows, right? Or I can go into the data viewer to make sure that my data is correct as well. So here I have some code that just applies some simple transformations. For example, just like removing null values and also just normalizing the values between the values of -1 and 1. And I'm assigning it to a new variable called df_Microsoft. So again, if I wanted to do a quick sanity check, I can just open it up in the data viewer again, and then I can leverage the powerful tools just by hitting, if I want to see the max and min values, I can see my minimum value is -1 and my maximum value is 1. So it's another great way that I can leverage this to use as a sanity check to make sure that my data is, or at least what I'm applying to my data is correct so far. Cool. So finally, the last step we'll need to do in the pre-processing is to actually convert the data to tensors. And tensors is just a variable type that Pytorch understands and works with. And you can think about it just like a matrix data type. Again, I've written the basic function to do this, but again, we can leverage the data viewer to see if it converts properly. So here, I'm just going to run this cell. You can see I'm splitting into the training and testing sets, and I can find the corresponding value of variables here. And I can see that they're now type tensor, which is what I'm expecting. And I can actually see the distribution between the test and training sets. So you can see the size of the training and test sets. And as well, you can see, even though it's three-dimensional, you can actually even still, we recently added support for both tensors, so being viewed in the data viewer, but also multi-dimensional tensors. So this is three-dimensional, and you might be asking, how does this actually render in this 2D grid? Well, we added this feature for multi-dimensional data, so three-dimensional higher, where you can actually slice your data. So slicing data essentially lets you take any two-dimensional slice of your multi-dimensional data and to just view that slice. So it makes it way more human readable, because if you didn't have that, you just look at arrays within arrays, which are kind of hard to read and understand and visualize. So having this type of UI makes it so much easier. And again, you can leverage either this drop-down, so you can see this is in sync, or you can use this text box if you want to do, if you're more familiar with that or comfortable with that as well. So for example, if I want to get some range, I can get, if I want to get the first 5, I can just do this to get the first 5 rows. And again, it's also another great sanity check to make sure that my values are still what they expect them to be. Cool, so now going back to the machine learning workflow, we just did our data exploration step where we imported our data and did a lot of data cleaning and pre-processing on them from the data viewer, as well as converting to tensors. The next part is training, where we're going to be figuring out which model we want to use and how we're going to train it. So there's several different models I can use to train the stock price predictor, but the two more common, well-known ones for this type of problem space are lstm and GRU-based models. And right now I'm not really sure which one will perform better, so I'm going to be testing out both models to compare their accuracy. But before I do so, I just want to show off a really quick cool feature, which is our IntelliSense support for Pytorch. So as you can see, here's my code for my lstm model that I've coded up. It's a really simple model, but even if you're somewhat familiar with Pytorch or new to Pytorch specifically, you might find the API kind of daunting. There's like a lot of APIs, and all the APIs have their own different parameters and arguments, and it's kind of hard to keep track of them all. So what's great is if I want to add another layer to this model, and I need to leverage the Pytorch package, so I can just do self.fullyconnected1 if I want to add another fully connected layer. And then you can see as I type neural net dot, you can see it gives me suggestions of the top APIs that are used by this neural net Pytorch framework, as well as it gives me the doc string, which is really nice because, for example, let's say I want to add like a dropout layer. If I go back to dropout, it gives me examples of how it's used, so I don't actually need to go back and forth between like Google or my web browser to figure out in Google Stack Overflow of how to use it. If I can just quickly see how it's used here, and as well as I type in this bracket, it gives me a parameter of what I need to do. So you can see here it expects a float, so I can just give it some sort of float of what percentage it's going to drop out. So it's really having IntelliSense built into VS Code for Pytorch. It just makes Pytorch development super easy and just takes the pain out of Pytorch development for you. Okay, so now getting back to the model development, the code explaining the models, like I mentioned before, is right here, but it's kind of hard to visualize to see its architecture, especially if you're not experienced with machine learning and Pytorch itself. So we'll be leveraging a tool called TensorBoard to help us. And TensorBoard is a free and open source dashboard companion that's made by Google to help Pytorch and TensorFlow developers both visualize attributes and aspects of their machine learning models and training. And it's one of the more popular tools that's used with Pytorch right now. So throughout my code, I've actually been logging information to the TensorBoard log files, which will then get read by this TensorBoard app itself and then parse into the UI that you'll see soon. So Pytorch is like a car. You can think of TensorBoard as like the dash in front of you. And what's great is one of the newest Pytorch features that's built into VS Code is built-in TensorBoard integration. So to launch it, you can either click on the code lens that you saw in the first cell. So if you have any imports that have TensorBoard, you can see this code lens appear. Or you can launch it anytime by opening up the command palette with Control-Shift-P or Command-Shift-P if you're on a Mac, and searching for the keyword launch TensorBoard. And when you launch it, by default, it'll use your current working directory because it knows what you have open in VS Code, and it's smart. VS Code is smart enough. Well, we'll actually search through its subdirectories to find log files. So traditionally with TensorBoard, you need to specify the exact folder it's in, but here it'll just automatically do that for you, or you can just select another folder. So I'm going to be launching this. So because it's in VS Code, I can make this bigger. So if I just close all this, you can see it's in full screen. I can make it any size I want. And yeah, getting back to the problem of the model architecture, we can actually navigate to this graphs tab, which I created, and we can actually interact with this lstm model in a much more human-readable format. So you can see here, I can see there's two layers in my model, the lstm linear layer, so it goes from input to lstm to linear to output. And you can see where this is really useful is most of the time you're going to be looking at someone else's Pytorch code, whether it's from GitHub or your colleagues, for the first time. And if you want to get a better understanding of how their model was built and how their model works, this is just a way easier way to look at it than having to look at the code. Cool, so now that we've developed our models and had a better understanding of the architecture, we can now actually run our training set against both the lstm and GRU models to see which one performs better. I previously ran the training, so everyone doesn't have to watch my code run for hours on end. But if you actually want to leverage faster compute, VS Code supports connecting your notebooks or Python file to a remote server via SSH. So if you just have installed this extension called remote SSH, you'll see this green thing up here at the bottom left, and then here you can just enter your SSH. You can click connect to host and enter your SSH, enter the IP address of your remote machine, whether it's in Azure or some cloud compute. And then VS Code will leverage that compute as its backend. And once the training is complete, we can go back to TensorBoard to see if the training on both models were trained properly by seeing if the loss functions converged. So we can kind of see the x-axis represents the number of epochs, but as the training went on, we can see that the loss of both models approached 0, which is a good sign because it's showing that both models are converging at some point. Going back to our graph, we can use going back to our notebook, we can use a test set that we saved to see how our model performs in the real world. And we clearly see, so this is a lstm model. It's not that great. We didn't expect that much because it was just a simple model, but if we go to the GRU section, which is the exact same code but just using a GRU-based model, we can see that the stock price performs much better, or the predicted stock price and the model performs much better, albeit still not like 100% accurate, but there's no way to get 100% accuracy at this point. So based on this, we're probably going to be sticking with the GRU model over the LSTM. And then finally, now that we know how our model code works, and we've been successfully able to train our model, we can try to optimize the training using the newly released Pytorch profiler. The Pytorch profiler is a joint project that's between Microsoft and Facebook. And to access the profiler, you'll just need the latest version of Pytorch, which at the time of the recording is just 1.8.1 installed, as well as a pip package named torch-tb-profiler, which VS Code will install for you if you don't have. But that's the plugin for TensorBoard to actually view the profiler. Once you have both installed, let me just show you the source code real quick, but it's really simple to profile your code. All you need to do is to import this torch.profiler statement, and then you just need to wrap your code. So you can see here, this is my training code, my training function. I just need to wrap it with this with statement, which is just telling the profiler to look at both the CPU and GPU, save the logs to this tab or this folder, which is where my TensorBoard logs are already being saved. And then I'm just telling it that when the end of an epoch is, so that the profiler knows how long an epoch is. So once that's all done, we can go back to the TensorBoard tab, and you'll see this Pytorch profiler tab, which if you have that pip package like I mentioned earlier installed. And this is what the Pytorch profiler overview view looks like. So let me just switch to like another example, but you can kind of see it gives you a step time breakdown of where time is spent during each iteration of your training. As you can see, where time is spent loading data versus running on the compute, etc. And also gives you a nice performance recommendation if it detects that there's any way where you can improve the speed of your training, because your CPU cycles cost you money, so you obviously want to save money there. So you can see in this example, it said that data loading took up around 22% of the time, and it gives me suggestions on how to parallelize that to speed that up. So I did another training job where that's being done, and you can see the purple, which represents the data loading, is now essentially gone because we've improved that step, and there's no more performance recommendations, which is really nice to see. There's so many things you can do with this TensorBoard, with the Pytorch profiler, so I would just look for the documentation there if you want to learn more about it. But the only other cool feature I want to point out, which is coming soon, is the ability to jump to source. So if I go into this operator view, which represents all the functions and how often they're getting called by my training job, let's say I want to see what is calling. Let's say I'm trying to find some inefficiencies in my code. I can see how many times, for example, what's calling this add function so often, right? I can click on this view call stack, view call frames, and if I find any user code, so let's say, I see here there's some code that I've written, I can click on this, and VS Code will automatically jump to this source code, and where you can quickly just see what is causing all these calls and make the edits necessary that you need to improve your performance of your training. Cool. So now that we've completed essentially completed the training job, we've fixed the inefficiencies of the data loader. If we want to share this code with others, we can use Git to deploy the code. VS Code has native Git integration, so we can just go into the source control tab you can see here, and you can just click on the notebook that you're working with. And what's great is, traditionally, if you ran a Git diff, you would see it all in JSON, which is kind of hard to read, but VS Code actually parses that all into a notebook-like interface, and you can actually see here exactly what I changed. So it's way nicer to read and makes it a lot easier to track the changes that you made in your Jupyter notebook. Yeah, so that's mostly it. The last part is just to save our model. So here I'm using the torch.save API and saving it as this file. And once that's actually saved, I can now deploy it to Azure, deploy it to any cloud that I choose. And what's great is VS Code has direct built-in integration with Azure services that you'll need for Pytorch. So like Azure Machine Learning if you want to run experiments, or Azure Functions if you want to host an endpoint for your model, or Azure Storage if you want to store your model to the cloud. And that's all done through this extensions tab. So you just search for the keyword, you'll find it. And then from there, I can just upload it to Azure within VS Code. Great. So just to summarize everything we've done today, I'll take it back to this machine learning workflow. So we started off with the data exploration, where we imported our data into our notebook. Then we did some data cleaning, data preprocessing by using the data viewer. And we also converted it to tensors and made sure using the data slicing that the values are what we expected it to be. Then we moved on to the training step, where we figured out which model to use between lstm and GRU. And we used TensorBoard to help us with that, to try to figure out not only what our model looks like and how it works, but also to figure out which one is performing better and to see if they actually perform well of what we expected it to. We leverage remote SSH if we want to make our training faster by leveraging remote compute. And finally, we leverage the the Pytorch profiler integration with VS Code to actually tune our model, right, by improving that data loading inefficiency. And we can also use jump to source, which is a feature that's coming out soon, to quickly make the changes as needed. And then finally, for inferencing, we just have the Azure extensions installed, and once that's done, it's super simple, right-click, deploys. And the key aspect of this entire machine learning workflow, as you saw, was everything was done in VS Code. I didn't need to switch between different tools to different tabs. Everything was done in this context, which is really nice to see. It's just the all-in-one tool for Pytorch. So what's next? If you want to build your own stock price model for the GitHub repo, you can just go to aka.ms/pytorch-stocks. And if you want to try Pytorch development yourself within VS Code, you can just go to aka.ms/python extension. So thank you so much for watching today. And we have a lot more exciting new features for Pytorch and data science coming up soon. So if you want to keep track of that, just follow us on Twitter. And thanks so much for watching.